How's it going, everybody? I'd like to welcome you to our Ike version 2 section, where we're going to be spending quite a bit of time on Ike version 2. And you might be wondering, well, why do you need to go through and do a bunch of Ike V2 stuff? Well, Flex VPN is the primary reason. But I wanted to cover Ike V2 because it's different than Ike version 1, significantly different. And as we go through this section, I'm actually going to start off with a Cisco document that really helped me understand how Ike version 2 works and how it correlates to how DMVPN, regular IPsec VPNs work, and how Flex VPN actually operates. Now, we're going to be spending a significant amount of time in this area and stuff like that, but before we get into any of the nitty-gritty details of how to implement things, I will be walking you through how the Ike V2 protocol portion of things works, because that's what you really need to understand from the ground up, is the day-to-day operations of what it does. So I'm actually going to redirect over here to this this particular document here, and the document actually does a really good job of breaking it down as to what Ike does and why it's different and things like that. And then we'll get into the some of the other details before we get into actually going through follow-on videos where we actually go implement it. So the way that this, let me go ahead and zoom in just a little bit for you guys so it's easier for you guys to see. I'll try to remember to link the document in the description. So basically, Ike version 1 was the first iteration of key exchange information. We've already covered that, and Ike version 1 is actually pretty easy to work with. Now, what ended up happening was Ike version 2 began development to try to address the shortcomings of Ike version 1. Now, we've seen Ike version 1 and stuff like that, and a lot of the additional capabilities that we've seen with Ike version 1, where we would have like dead peer detection and timers and a bunch of other stuff, these were capabilities that were added to the Ike standard, which is just a framework of individual processes and protocols to help glue together what we know today as IPsec VPNs. Now, Ike is going to be phase 1, right? It's going to be the propagation or the exchange of authentication materials, whether that's a pre-shared key or a certificate-based implementation. So, when you take a look at the Ike Packet Exchange for Ike V1, you have the initial aspect of it to where you go through the phase 1 policy. So you compare things like the, because Ike is going to be the control plane communication. So your encryption, your authentication, your pre-shared key, all that type of stuff. Then you go through your nonces and your NAT traversal. So nonces are going to be numbers used only once, and some randomization that comes into play. And then once this process has completed and everybody can agree on all the details that go into that, then you dive into your encryption piece, where you start going through and setting up the essays and all of that type of stuff, and eventually you get a VPN up and running, right? Where Ike version 2 it has a lot of the same capabilities and stuff like that, except for it's technically one phase, right? Where Ike version 1 is actually, Ike and IPsec are two different phases. You have Ike, which is your first phase, which is highlighted right here. It's all this stuff up here, these first 4 exchanges. And then you have your QM idle, and then you have your phase 2, which is your actual IPsec security association, or your SAs are exchanged to spin up the actual data encryption. Ike version 2 doesn't have a second phase, as you can see. The way that they correlate it is you have your Ike SA init, which is going to be the communication back and forth initially. Then you're going to have your Ike auth. This is going to be where you exchange your authentication information, and then your SA, so your security association. If you're going to do additional capabilities like EAP, the Extensible Authentication Protocol, there are going to be things we're going to be taking a look later on where we have to leverage EAP to do certain things. But those capabilities would come into play in here, and then you finally have your child SA. A child SA basically is going to be your SA, your IPsec portion of the setup. So this is going to be where the data is actually encrypted. So everything before that is going to be all of your authentication mechanisms. So that's the big deal with that. So the way that Ike version 2 works is the first thing you have is the SA init. The SA init is going to focus on the initiation. So you're going to send the SA, the key exchange, the nonces, and stuff like that. That's all that stuff is going to go back and forth during this portion of the setup. And then once all those details have been exchanged, then you're going to go through the process of going through the auth exchange, where the setup here, you go through and you go with the payload, with you, whether you're using a pre-shared key or signature or ECDSA, stuff like that. And then when you go to set up your child SA, this is basically the IPsec portion of that when it goes through all the details of getting all that type of stuff set up. So these are the details that are related to that. Now what's cool about this is a bunch of these additional capabilities are what give Ike its additional functionality. So there are, we'll be taking a look at ASA, Ike V2, and stuff like that, setting it up an Ike V2 site-to-site VPN and things like that. That's pretty much as far as ASA takes Flex VPN. So let's talk momentarily about what is Flex VPN. So we're not really at that level yet. We still actually haven't even hit Flex VPN. You might say, well, what's the difference? Well, the difference is how it's implemented. Okay, if you simply take Ike V2 as the keying technology, and you go through and you configure all the details, you go through. I'll take a look at the policies and the proposal and all that type of stuff here in just a minute. But until you actually start using the dynamic virtual tunnel interface and doing DVTI and stuff like that, if you're just using crypto maps or IPsec profiles or any of that type of stuff, you technically haven't jumped off the Flex VPN yet. Even though, if you were to look at the secure configuration guide, it says Flex VPN and Ike version 2 configuration guide, and you click on that, there's a bunch of stuff in here that says Flex VPN, right? Well, I've been going through this stuff, and basically where my understanding comes into play, this is just for me going through and looking at how it's configured. When you configure Flex VPN, or when you're working with Ike version 2, and you don't leverage a DVTI or dynamic virtual tunnel interface, that's really, in my mind, where I had to draw a line in the sand that says, okay, the moment I start using DVTI on the hub side to dynamically form individual virtual access connections down to the spokes, and then DVTI on the spoke side to spin up on-demand site-to-site VPNs between the spokes, I still haven't hit the Flex VPN threshold yet. I'm just using Ike version 2 to go through and do the keying exchange. So we're going to be taking a look at a lot of different capabilities when it comes to how Ike V2 is working. So basically everything we've covered so far in terms of crypto map and IPsec profile and all that type of stuff, we're going to go back through it, but with Ike version 2. And the big difference here, and I actually want to spend some time on how Ike V2 works, because that's going to be the core capabilities that we're going to go through. And then we're going to take a look at diving into, down the road, we'll look at doing next generation encryption and certificates and all that type of stuff. That'll come into play as we progress. So I want to first start off with there's some details in here that we can take a look at. So we'll start off at the very top here, where we can use IPsec to do the spin up of Ike version 2. And so things like DES and MD5, we won't really be leveraging those at all. We will be looking at things like, I'll look at triple DES and AES 128. There will be several videos that we'll do where we'll have a less strong or a weaker encryption, if you will, where next generation encryption will be looking at the very, very high end stuff, and we'll take a look at exactly how that comes into play and go from there. But you can see that we have AES and SHA and all those type of stuff like that. Those capabilities are still here. They haven't gone away. Now, what's cool is Two of the main things that are roped into Ike version 2 out of the gate is DPD, or dead peer detection, as well as NAT translation and traversal. So we'll be taking a look at those details as well when we start diving into this. Now, when it comes down to how this stuff works, I'm actually going to bypass some of these other minor details because they're technically part of Ike, and we'll take a look at debugs and Wireshark captures as we're going along so we can understand it better. But the constructs, Ike version 2 is not going to be the easiest thing initially to go through. There's a lot of little things called what they refer to as smart defaults. Smart defaults are going to be things that are configured and on by default on iOS and iOS XE. We're going to be mainly focusing on iOS XE because most of your iOS-based routers are going to be going away. I mean, they're still deployed, but nowadays with the ISR 4K and the ISR 1000 and the ASR platform and so on and so forth, I do see as more and more companies go into the next wave of their network refreshes at this point in time. We're in 2020 now, so I do definitely see a lot of companies moving away from the ISR G2, 2900 to 3900, stuff like that. They're going to move into the 4K and continue moving forward with that. So the first thing we need to understand is going to be the proposal. Now this would be like your Ike V1 policy. You go into policy and you'd specify the encryption, the authentication, the group, and the hash, right? Well, some of these things have been minimized. So what's actually kind of funny is the integrity and the pseudo random function are pretty much the exact same thing. It's a hashing, right? Then we have DH, Diffie-Hellman, and we have the encryption. So that's going to be the replacement for your Ike V1 policy. Okay, your ISACAM policy if you're on a router. If you're on an ASA, it's going to be an Ike V1 policy. The policy itself, when we go through and play it and take a look at exactly how this works, this is going to call the proposal, and then you're going to call the policy later on. The profile is going to be what is used to define certain attributes. Now, what's interesting about this is the profile is going to have a bunch of characteristics in it that are rather involved. So we'll take a look at the details that go into how that stuff works here just momentarily. Then you have the key ring. Now, what's interesting about the key ring and the profile is I've gone through a bunch of Ike V2 training. I've labbed up quite a bit of the capabilities, and I found that you can either have the profile or you can have the key ring, but you don't necessarily have to have the key ring. If you're not using pre-shared keys, if you're using certificate-based authentication, you don't need a key ring at all. If you are going to be using the profile and you want to create the pre-shared key in the profile, you can do that and never call a key ring. Key rings are optional, although I have seen them say that they are required, which is not the case. So we'll be taking a look at that as we go along as well. Then we get into smart defaults. Again, these are going to be the on, out of the gate, for you configurations. And there's quite a few of them that are operational. So here are some of the different defaults. You have the Ike V2 authorization policy, which is the authorization policy is basically going to allow Ike V2 routing. So you're like, wait, hold on, it can handle routing? It can actually propagate things like the local interface configurations and stuff like that. It can propagate routing and whatnot between the devices. And I think I found a bug. I'm pretty sure I found a bug. The reason I say I think I found a bug is when we get further on down the road and we start getting into using the Ike version 2 authorization, and we get into, I'm trying to remember what the exact setup that I was running into. But basically I had a hub and I had 3 spokes. It wasn't Flex VPN quite yet, but we were like right on that cusp. And what I was doing was, actually no, it was DVT. It was DVTI, it was, now that I think about it. And what was happening was I would configure the spoke to peer with the hub, but what would end up happening is we would see a virtual access connection come up on the hub, but we would never see a static route propagated by the spoke to the hub, so the hub would never know how to reach back to the spoke. And so therefore the IBGP peering for the dynamic neighbors that we're going to be taking a look at for very large-scale Flex VPN deployments, I definitely recommend BGP. It wouldn't work. So I had to come up with a workaround to actually propagate it by default, and then we would see it show up in the routing table. I'll show you what that looks like. But it's one of those things where I was racking my brain for probably the better part of a few hours trying to figure out how to make this work. And then when I saw the routing, I was like, oh, this actually could work. So I tried it, and it did work. But it was one of those things where I was like, that's a little unusual. But, it is what it is. So the proposal is going to be obviously a group of algorithms and protocols that are sent to the other side and used for the exchange. So there's going to be a default proposal, and initially we're going to be using a lot of the defaults. Then we're going to turn a lot of the defaults off and manually configure stuff. There's a Ike V2 policy by default as well, which is going to specify it's going to call the default proposal, and it calls the proposal right there. The match address local, it's going to say any address. It's not going to care. And we're going to match, it's called the Ike V2 default policy. And when it says the front door VRF, it's going to say any VRF. And by default, it's going to be matching on the default VRF, which is the global routing table. Then we have the IPsec profile, and we have the IPsec transform set. What's actually pretty interesting about this is the transform set comes before the profile does. And when we go to create our crypto maps and call, if you don't specify a transform set, it automatically calls the default transform set. So that'll be something we're going to take a look at. And I'm actually going to have to circle back to Ike V1. I don't think I actually demoed this, but I'll circle back and add some videos to it. But the way that this works is you have this transform set called default that's calling ESP AES, and ESP SHA HMAC for the encryption and the hashing that goes along with that. So then you see that it's a negotiation of tunnel. And then in the profile it calls the same same IPsec transform set. So what's cool about this is if you don't specify anything, it'll automatically call the transform set that you want in the crypto map, and if you don't specify a profile, it'll call the profile for you. Or when you go underneath the tunnel interface to go configure this stuff, and you say the IPsec profile default, it'll call this profile, which will call this transform set. It's actually pretty interesting how it all comes together. So the way that this works, and we'll take a look at Suite B and GCM down the road. One of the cool capabilities of auto mode is, regardless of what the spoke is configured for, if it's configured for a crypto map, GRE tunnel, or raw IPsec with the IPsec IPv4 mode, so tunnel mode IPsec IPv4, it'll detect that. And if it detects that, it'll automatically allow that connection to come in, and we'll take a look at exactly how that works. For those of you that need to have a deployment where you need to make like DMVPN with Ike V2, but you're not going to be relying on NHRP to do the exchange, you're going to be falling back to Ike V2 to do the exchange, but you need spoke-to-spoke communication, and you need the spoke to be set up for shortcut and the hub to be set up for redirect. You're going to want the tunnel mode of GRE over IPsec. I'm sorry, GRE IP, and or it's a tunnel mode GRE multipoint, and that will allow DMVPN, what I call Phase 4. Phase 4 will kick into play, and you'll be off to the races. Now, there are some additional phases that are out there. Are these documented where you could go look up DMVPN Phase 4 and it's like, oh yeah, here it is? No, but it's like the next level of encryption capability. So for those of you that have done DMVPN Phase 1, 2, and 3 with Ike version 1 and done the spoke-to-spoke communication via Phase 1, or I'm sorry, Ike V1, then you migrate to Ike V2. That's what I consider DMVPN Phase 4. There is another one beyond that called Phase 5. And you're like, how many phases are there? To my count, there's 5. And the 5th phase is where you are going to be running Lisp with encryption. And you're not technically using NHRP, but it's like a DMVPN like operation, but it's not actually DMVPN. But anyway, that's just my take on the evolution of the capability. But if you want to allow spoke-to-spoke communication, you're not going to want to use IPv6, IPsec, IPv4, or crypto maps. You're going to want tunnel mode G or multipoint. And then when you get into the details of how this will come into play, there's a lot of details that go into what you need to have for the configuration. So let me actually scoop past all this stuff, because a lot of this information that's going to be here, it's going to be a lot of, it's going to be kind of hard to interpret. I actually like to look at the final the configuration examples. So let's come down here to the bottom. There's configuration examples here at the bottom. Let me scoot all the way. Let me come up here a little bit. And so this would be the configuration it's trying to give with the FQDN. And here we go. So the key ring here is separate. This is going to be no different than your crypto ISACAM key, and then you specify a key. Same concept here, except for you had to specify a peer, and then you had to specify how you're going to be talking to them. So whether it's going to be via IP address, or it's going to be via a domain name, or whatever the case might be. I actually want to show you the proposal first. Let's come down here to the proposal. Here we go. So we have an Ike V2. Let me go ahead and zoom in a little bit for you guys so it's easier for you guys to see. Oh, too far. Let's find that again real quick. Should be right here. Here's a proposal. The proposal that we want to send, this would be an example of one transform. So we're sending the proposal over. Encryption would be AES cipher block chaining, and then 128 with the integrity of SHA and a group of 14. Here's where you can send multiple transforms. So during the negotiation, you could be sending multiple transforms. It's definitely an option if you want to do that. Now, if you, we're going to be, in this case here, they're doing multiple integrity and multiple groups and stuff like that. Come down to the policy. The policy is calling a user-created VRF, and so in this particular case, there's a user-created VRF, and it's matching proposal 1, which is fine. And then we come down a little bit further. If you're going to do this, you would just say match proposal 1, or whatever the proposal name is going to be. And when we go through our examples, it's going to be very obvious what it's calling. So as I make mine, Ike V2 proposal, Ike V2 policy, etc., etc. We come down a little bit further. Here's a proposal matching all peers in any VRF. So we're just saying match VRF any, which is, we're not even going to specify a VRF until we get to VRF aware Ike V2. And then when we come down here, after we go through that, then we're going to scroll back up to the top here, where we have the key ring. Here's this key ring. So what's cool about this is you can do either a symmetric pre-shared key where you have the same key. So here we have ABC key 1, and let's see here. It's, in this case here, it's not exactly telling you what's happening, because the when you're configuring this, there's actually a way to do a pre-shared key local and a pre-shared key remote. And if the keys, this one here is symmetric, but here is asymmetric. So this would be symmetric, where you'd send the local key out over, where I would specify a local key of key 1, remote key of key 2, etc. And you can do that, that's one of the first bigger deals. The one that's even cooler than that is you can do one side's pre-shared key, one side's cryptography, or I'm sorry, certificates. So you would just name, remote would be RSA. So you would match on that, and then you would go through your configuration, and it would work as long as the local device that's doing pre-shared key has imported the certificate. and is aware of it. If not, then that would be a problem. So we come down here a little bit further. We have the profile. You would come underneath here, the profile. You'd say match identity, remote, and then you would specify remote. And you could be as granular or as wide as you like. So we could say, and when we initially do it, we can be very specific. And then as we grow and grow and grow, we could have match identity remote. We could say any for the most part, or just an all zero. So we don't care who the source IP address is. With the local, we're going to specify who we are. The local would be pre-shared key, and then the remote would be, so in this case here, it's calling a certificate. We are, for the key ring locally, we're saying key ring 1, so that when we send traffic over to the other peer, then we're sending the pre-shared key in this particular key ring. And then here we're saying, we're calling the certificate, or the PKI trust point that's going to match on this RSA key, or I'm sorry, this certificate. So we know we're verifying based off of this information right here. We're saying that the this particular connection will come up for 300 seconds. The DPD is going to be on. It's going to send it's going to send a hello or a DPD message every 5 seconds, and it's on demand. I forget the 5 seconds. There's 2 attributes here. I can't remember exactly how they're broken down. It's like once every 5 second ping, something like that. We'll have to dive into that a little bit more in detail. But here in this example here, we're doing a virtual template 1 where we're going to be doing DBTI. So we're going to call DBTI, and if this was a hub, this would basically be how you would go out and do dynamic peerings to your other spokes. If this was a spoke, this would be spoke-to-spoke communication. Then we have here's this one where we're doing a combination of both local RSA, remote pre-shared key, and remote certificate. And we're setting the pre-shared key has been, the key ring has been mapped for pre-shared key authentication. And then we're doing the trust point local and remote sign and verify. And what's interesting is the identity local, they're saying, is this guy right here. We're going to be using identity local is going to be DN for a distinguished name. And that seems to work really, really well, because we're not actually going to have a live deployment. So this won't be something that's going to be publicly reachable. It's in a lab. So there's a lot of limitations that I'm running into. I will have legitimate certificates propagated. We'll go through a PKI server and we'll get all that stuff squared away. But we won't have like router to a Cisco.com. We won't be doing that. And then a lot of these other capabilities come into play. We have our profile. I don't see a proposal. I see a SVTI where we're setting the IPv2 profile and things like that. So there's a lot of capabilities that come into play with how this all works and stuff like that. It's actually pretty cool when you start getting into the weeds of how it all works. But we are going to do a crawl, walk, run approach. So we're going to be using IP2 with crypto maps initially and going through all those steps, because if we just dove into Flex VPN, you'd be missing a lot of the core competencies that I think would definitely be necessary, even though on the new CCNP exams that at the date of this recording, it's the 23rd of February, will be coming out. We'll start on tomorrow. So I'm probably going to be booking exams or the VPN exams probably sometime in March is my guess. But I'm going through and I want to go through and play around with the stuff in a live environment. I've already demoed a lot of it. When we're going to be going through a lot of that, there's still a lot of stuff that I have to go play around with. But I wouldn't say a lot. There's still some things that I have to go play around with. Like I haven't added ICE to my lab yet, and Active Directory authentication. So, like crypto-based, doing anything that's requiring AD authentication or Radius or TACACS or anything like that hasn't been added yet. And those to me are going to be more CCIE level details that I would need to dive into. So I'll be taking a look at those at later times, but I want to get through the main stuff first of IKEv2. So what can you expect in terms of our real or the rest of our setup here? Well, let me come over here, and this is the topology we've been using for quite some time. We're going to continue, but we're going to flip over to Ike version 2. And the way that we're going to do this is that when we get into the details, we're going to start off with crypto masks with pre-shared keys that are symmetric, then asymmetric. Then we're going to be using on iOS and ASA. Then we're going to dive into GRE over IPsec. Then we're going to dive into VTI tunnels on both the iOS and the ASA. And then we're going to get into DMVPN, then GetVPN, and then we'll get into Flex VPN. Actually, GetVPN will come later on down the road because GetVPN is going to require a complete rebuild, and I'm holding off on GetVPN until I've gotten everything else squared away. We're going to spend quite a bit of time on DMVPN or Flex VPN and all of its capabilities because there's a lot of little things that need to be played with and messed around with, and we'll go take care of those as we're going along. But there's going to be a lot of stuff coming out that's related to Flex VPN because of what we need to cover. So that is that, ladies and gentlemen. So if you have a request and you want to see it put down in the comment section below, go for it, and I'll see what I can do. Until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.